Hey there, guys. I think last time we left off here with bind, so this will be sort of part 2 of bind. And this time we're going to do some code diving and have a look at some other implementations. So just for a quick review, in our implementation we passed in a context, and then we had a string method that we used to look up the property, and what we did was we returned an anonymous function. What I didn't say, I don't think, was that this is also, it's an anonymous function, but it's also a closure. And that's why even after the first outer function returns, we can still see these parameters because it said that this outer function closes over the inner function, the closure, and so we still see these variables. Probably something that we'll need to provide some more treatment on and look at more deeply later, but let's just note that this function is returned as a result of calling the outer function. So, and if this doesn't make sense, probably go back and look at the first video. So let's look at underscores bind. And we're going to, I looked at a few different implementations of bind, and I'm going to pick ones that seem somewhat closest to ours. And there's some libraries that will call a lot of helpers internally, and so once you kind of uncover what those references are and mean, it becomes more clear. But I think for this exercise, I'm going to go with the ones that look like they're a little easier to grok. So let's actually mess with this guy and just make it so we can tweak him. In underscore, this is going to get attached to this underscore object, but we're just trying to have a look at sort of how this thing works at its core. And he's using different spacing than I am, but we'll just sort of refactor this to, and so native bind, so let's create what we think native bind is. That's going to be Function.prototype.bind. Okay, and let's put this on a second line. So basically, we're going to say if our function has a bind method and it equals native bind, and we in fact have native bind, then we're going to just call native bind and apply our function as the scope, or rather, we'll pass this function and the scope will be the context we provide here. So I've kept ours around, so we've sort of flipped these. We had context and method. This time we're really doing method and context, although we're calling it func. So let's now go down here. If we get down to here, then we did not have a native bind, right? And so for this guy, we're going to basically get the first call to bind's extra arguments. So we have 2 arguments. So slice, this is the array prototype function. So they've normalized it over to just slice, but we're going to call it that way. And they're using call instead of apply. Okay, so now if we reformat this a little bit, we can see that this starts to look quite a bit like ours, except what's going on here? So they're slicing out the additional arguments and stuffing it in args. And this is happening before we return this anonymous function, this closure. So what's happening here is when we later have this anonymous function called, we're going to concatenate the initial set of arguments with the arguments on the second call. So it's as if, I'll just type it down here, if we were going to say var function equals bind some function to some context like this, and then we said A, B, C, and then later we called this with X, Y, Z. Between the two of these, once we made this call up here, we'd have A, B, C, which would be here, and we'd have X, Y, Z over here. Now, wow, is that a mind bender or what? So what we're doing is we're partially applying the initial set of extra arguments into our function object. One way I've heard this is we've baked in those arguments, or we've basically attached them to this function object, and then we call and we add more arguments. So that's called partial application. And I think you can also call it currying, but it's actually very similar to rbind, except rbind did not provide for the partial arguments, right? We just grab the arguments when you call it. So let's actually comment out rbind and start to use this. So we've named it the same thing, and we've got to switch our arguments around. So we're let's see. So actually, they're passing an actual function. We were passing a string. So we need to pass this function here. This is the one we want to call with. So we want to pass this function, but we want to give it the scope of the OBJ, right? So let's try to get this running now. Let me find my file. That would be this one. And let's open up our console. I have an error on line 15. Let me fix that up. Function bind equals function. Yeah, we don't need to do that. Okay. Slice is not defined, and that's on 18. I didn't fix this in all places. Okay. Okay. So now I think we should be okay. If we click, now we've got the same resulting behavior as in the first video, where we click this. Let's sort of walk through this. We click this button, and when we click the button, we've already bound this function, but with the scope of object. So actually, let's back up. Let's first look at this call to bind. That's going to come in here. The object handler here is our func, and then the obj here is our context. We actually probably have a native bind, so that's what's actually going to happen for real. We can prove that here just by going like this, right? And you can see it exists. But if it didn't exist, we'd come down in here, and this would be our shim. So let's put a big comment. This is the native version, and then this would be the shim. Oops. All right. Okay, so I'll take those comments out. So let's just say that we didn't have this in this browser. Then we would grab our initial args, and then we'd return this closure, and that would be basically the result of all this. and that closure would get passed into the event listening or the event system. And when we clicked the button, this closure would actually get called, um, and that would return the results of applying um, our function with the context of what we initially passed over. And again, this is a closure, and in a closure, you still can see variables even after the outer function has went out of scope. It still sticks. These guys still stick around, and so we can call them in here, and we concatenate whatever additional arguments there are. Um, Prototype has a bind. I'm not going to go over this too much, but it's very similar. And instead of an anonymous function, you can see over here there's a bound. So this anonymous function here, our function expression is getting stuffed into bound, and then they eventually return it. And they're actually setting the prototype on this. But for all intensive purposes, this merge is the same as running, doing the concatenation that we saw earlier, and it's doing more checks, but it's taking the method and it's applying the context and the arguments and doing the same general thing. A lot of defensive coding up here. Um, if the arguments aren't the correct length, it's just going to return this. If the context is undefined, um, and if this is not a function. So there's a lot of defensive coding going on here and some more stuff. So it's more thorough, but the kind of core essence of what it's doing is the same. Let's take a look at the hitch function, which is in Dojo. And if we were actually to take this guy, well, we'll take this whole guy and let's refactor him. Refactor is kind of a dirty word in this case. Let's butcher him into uh, into our example. We're just simply trying to get a look at this outside of the Dojo ecosystem, which would require us to use their module loading system and everything. We just want to kind of look at this. So we can actually take this and sort of refactor it. And sorry, Dojo authors, we're just kind of playing around with this. So let's take this stuff. If arguments, so we don't have access to this hitch args. That's another function in the laying module of Dojo. So we're not going to worry about the defensive coding. We had a quick look. So we'll take that out. If not method, so we can leave this in. This is basically saying if we don't have a second argument, flip the second, let's make the method scope. So it's a trick basically saying that if we don't have two arguments, scope is actually going to become method, right? They copy scope into method and then make scope null. Kind of cool. So then they do something interesting. They say if the method is a string, which we can do this way. Again, we're killing off any specific helper functions that they've done. Like Dojo Global might be window, we don't know. So we're just changing this so we can sort of see the core of what it does. And then he's doing this thing where he's concatenating a string by joining an array, which, well, the jury's out on that for small strings like that. Let's just make this a little more readable. Hitch, throw a hitch error. This is not meant for production again. So let's see here. So now if we look at this type of method equals string, then in this case, we're going to take the scope that was passed in, or window if it wasn't, and then we're going to say if if scope doesn't have a method on it, then we'll throw an error. But otherwise, what are we going to do? We're going to return a closure, and let's make this look sort of similar to our old implementation. It should be starting to look, here's our closure, and then we're simply going to call scope method apply. So this is the same thing that we basically had right here, but what they do, which is kind of nice, is say you actually pass in a method that's not a string, it's the actual function, which was what we saw with underscore implementation. Well, if that's true, then we won't even go into this block, right? Because it's not going to be type of string. And in that case, if it was called with only one argument, as you recall over here, we shoved method over into scope and then called it method and deleted scope. This is a little trick for if the two arg method only gets called with one. And if so, down here, if scope doesn't exist, then we know we did that and we have a method, and we just return that. Otherwise, we this time we actually apply. I'm going to reformat this. This time we actually apply on the method itself rather than having to look it up in the as a property of our object. So that's kind of cool. So it'll work either way. I'll leave actually exercising this hitch function as an exercise, or will I? Let's just do it. This video is already probably too long. So let's see, we said scope. So now we're back to the scope comes first and then the method. So let's try it without using a method instead of a string. Okay, so the method is going to actually be a method. I think I've done this correctly. No, I haven't. On 14, I've got an extra parenthesis hanging around. Now I'm on 25, and this used to be a method, so now it's actually 34. What did I do here? It's an unexpected end of input. That's not good. Here's an object literal. So I probably have a missing hitch takes these two guys. Okay, I probably did something up here. Welcome to Rob debugging. Ah, that doesn't look good. Okay, so I created some I created some madness over here. Okay, so now we can do this. Alright, so we're getting the same effects. And let's just recall this true is an answer to this statement here, console log that this is actually this object, right? And if we now change this to a string, it should also work because it's handling both implementations. And if we kind of want to prove this, we'll say that method version, and this will be called the string version, just so we can differentiate, right? So right now we're using the string. So when we click this, we see in the string version up here, and that's all because the type of method was a string. If it's not a string, if it's the actual method itself, we'll get this. And reload, and I promise we're almost done. And now we're in the method version. So there's a pretty detailed look. I went as fast as I could. We looked at underscore, a little prototype, probably a little too quickly. We looked at the Dojo lang hitch function. So those are essentially three implementations of the bind shim. Again, if you have the native version, supposedly No Dash says that V8's version's slow. I don't know. I saw that in their source code. I haven't investigated that yet, but usually I think you'd want to use the native one if it's there. So that's about all I have on this. This is sort of the first time we've actually sort of went code diving. I'm going to try to do this a lot more. Let me know what you think. And by the way, if you like these things, plus one it. Maybe do a Google plus or Facebook on it. I'm I'm not being very aggressive about marketing these, so I could use any help you can give me. So that's about it for today. Thanks.